Welcome back to the 3ds Max Basic Modeling online class. I am your instructor, Zhang Ying. In this lesson, we officially begin high poly modeling. We will use 3 mechanical parts arranged from easy to difficult as case studies. This will demonstrate the workflow from mid-poly modeling and adding supporting edges through to high poly modeling. A journey of 1,000 miles begins with a single step. Small streams make a mighty river. Although these 3 parts are simple, they will train your basic modeling mindset and lay the foundation for more advanced high poly modeling.
Instructor, what's the difference between mid-poly and low-poly?
Back in chapter 1 of this course, we introduced the concepts of low poly, mid-poly, and high poly models. The biggest difference between mid-poly and low-poly lies in their purpose. Mid-poly is one of the steps in creating a high-poly model. Its main goal is to establish the overall form and provide the structure for the high-poly model. When creating mid-poly models, in preparation for adding supporting edges, keep faces primarily in quads and separate components into parts. The main goal of low poly is to reduce the polygon count while maintaining sufficient visual quality, ensuring real-time rendering performance and efficiency.
I see. We can't wait to try these different workflows.
Alright, now follow me and open 3ds Max so we can start together. First, place the reference image at the top of the viewport. Ensure the front view orientation. Drag out a box cuboid in the viewport. Adjust its length, width, and height to form a cube. Press F4 to enable wireframe. Press the plus key to increase the transform gizmo size. Then reset X, Y, and Z coordinates to 0. Right-click and convert it to editable poly. Select these 2 polygons, and from the right-click menu, find Extrude. Open the Extrude dialog. Set the extrusion value equal to the cube's dimensions, 30. Now you have 3 stacked cubes. Press M to open the material editor. Change the material color of the first part to red. Switch to a black wireframe. Now, let's create the second part. Create a cylinder in the viewport. Keep it short. Turn off the height segments. Set the sides to 16. Convert it to editable poly. Press T to switch to the top view. Switch to the vertex sub-object level. Drag select all the horizontal vertices. Press Ctrl plus Shift plus E to connect them. Then drag select the vertices on the lower half. Rotate the viewport. Press F3 to display the shaded model. Press Backspace. Delete the selected vertices. Now, the cylinder has been cut in half. Select these 2 edges, right-click and choose Connect. Connect to create 2 new edges. Select the polygon in the middle of the connected edges. Right-click and open the Extrude dialog. Extrude to add thickness. Press T for the top view, then drag select the vertices. Scale the shape slightly. This makes it closer to the reference image. We use drag select to pick both the top and bottom vertices at once. Now select all the polygons on the top. Hold Ctrl to add to the selection. Right-click, choose Bevel, and add some thickness. Rotate to match the angle in the reference. Observe the result. Adjust the thickness again if needed. Select this edge and activate ring selection. Right-click and choose Connect. Connect to create a new edge loop. Then select vertices on the polygon. Press Ctrl+Shift+E to connect them. If the overall shape looks too thick, select the top vertices and move them downward. Go back to the vertex sub-object level. Right-click and choose Cut. Use Cut to connect vertices and keep quads. Do the same for the lower polygons. Keep the entire model mostly in quads. Press M to open the material editor. Assign a green material to the object. Change the wireframe color to black. Move it aside once done. Now let's create the third part. Again, create a cylinder. We are currently in the orthographic view. Press P to switch to the perspective view. Set the sides parameter to 25. Right-click and convert to editable poly. Select the top polygons. Right-click and choose Bevel. Adjust both height and scale. This will be the first layer. After finishing, click the plus button to add another layer. Take a look at our reference image. We'll need multiple layers here, so we'll add them several times using the plus button. Adjust the scale slightly, then click the plus button again. I hope you're following along with me. I added a few edge loops. Try to match the same number of edge loops, although it's just a bevel without any thickness for now. Every loop here will be useful in the next step. When I move on to the next step, you'll see what I mean. Now switch to the vertex sub-object level. Connect these 4 vertices together. Leave a gap of 2 polygons between each connection, just like I'm showing here. Can you see what I'm connecting now? I'm building the 5 petal positions. Now, the 5 petal segments are in place. Double-click to loop select these edges. Hold Ctrl to add to the selection, then press Ctrl plus backspace to remove both edges and their vertices. Go back to the vertex level. Select the very center vertex. Hold Ctrl and click to select all connected polygons. Now, all faces linked to that vertex are selected. Click Grow Selection. See, this is the area that needs to be pushed inward. Right-click and choose Extrude. Lower the height slightly. Click the checkmark to confirm. Now repeat the same method for the center vertex again. Hold Ctrl and select the faces. That selects the entire loop of polygons. Right-click and choose Extrude again. Extrude it up slightly. Now, the petal shape is formed. Look at the bottom face. It shouldn't remain an N-gon. Delete this face. Select the border. Hold Shift and Scale to create a copy of the border. Right-click and choose Collapse. Collapse the border to a single vertex. Now, the bottom topology is complete. Press M to open the material editor. Assign a material with the same color as the reference image. Also change the wireframe to black. That completes the mid-poly models of all 3 parts. Alright, that's the end of today's lesson. See you next time.